Hello, I am Dr. G and I'm glad to meet you at my channel. Today we consider a system of two equations containing two unknowns x and y and which contain also the unknown parameter a. One equation is logarithmic and one is quadratic. The goal is to find all value of a for which the system has two real solutions. Let's consider outline of solution. First, we will analyze equation 1 and we will find domain of logarithm and relationship between y and x. Next, we analyze equation 2 and we find some restrictions for parameter a. And finally, we will combine what we found from previous analysis and we will find solutions to the system and the range of parameter a. Let's go to the first step. We have equation 1, logarithmic equation, and to analyze it we should recollect the properties of logarithm. First, we consider definition of logarithm. In this definition, argument is greater than 0, base is greater than 0, and not equal to 1. Applying what we have here to our case, we have that in our system x must be greater than 0, y must be greater than 0, and in addition, y is not equal to 1. Then we use the next property of logarithm. If log a of x equal b, then x equal a to power b. Applying this for our case, we get the following, that y is equal x. So we got a lot of information from the first step. Now we will analyze equation 2, which is here. We know that y is equal x, so we can rewrite it in this form. We move x to the left, and we simplify equation a little, and we denote it as equation 3. Now we need to recollect some information about quadratic equation, concept of discriminant, which is given by this formula, and solutions of quadratic equation are given by this formula. We see that if discriminant is greater than 0, we have two different roots. We apply concept of discriminant here. We can calculate discriminant. So it is here. We factor 4. And we have this formula. Then we know that equation 3 has two solutions if discriminant greater than 0. So we use this in this form. So we have for a such an inequality. It's very simple. We can conclude that a must be smaller than 4. I just want to mention that this inequality means that a can be negative, because any negative number is smaller than any positive number. We will use this inequality later. Now we go to the third step, finding solution to the system and the range of parameter a. We start with the second equation in this form, and we will use what we know about solutions of quadratic equation, and we find solution for a smaller than 4. Discriminant equal to this value. So we have the following formula for two solutions. We can factor 2, move from the square root. So we have this equation. Next, we can cancel 2. And we have this simple formula for two roots of quadratic equation. x1 we select 2 plus the square root. Correspondingly, first solution for y is equal x1. Similarly, we can write equation for x2 and y2 equal x2. So now we know the roots of this equation at a smaller than 4. But this is not final answer because we didn't take into account restrictions for y and x which we found previously. They are shown here. First, we consider restriction on x. X must be greater than 0. The same restriction will be applied to y because x equal y in our case. So for x greater than 0, first root of quadratic equation is greater than 0 because here is positive 2 and here is positive square root. So for any a smaller than 4. The second root we should analyze because here is a difference. We move the root to the right, and it is clear that here a is greater than 0. In this case, this square root is smaller than 2. We combine these two inequalities and get this answer. We will use this answer later. Now we consider restrictions on y. Y greater than 0 we already found a restriction. It leads to the same inequality for a. Now we consider y not equal to 1. Because x equal to y, the same inequality is applied to x. And again we analyze the roots of quadratic equation. x1 equal 2 plus square root. Definitely it is not equal to 1 because here 2, here is a positive square root. So for any a from this interval we have this inequality. Equation 2 we should analyze separately. So we write this in the form a not equal to 3. It's evident that only at a equals 3, x2 equal 1. So we have to combine these two inequalities to get the final answer. Two solutions exist at a, which is given by this formula. We use here interval notation. So the problem is solved completely, and this is the final answer.